Good afternoon and welcome to the Grasscast and Drought Monitor webinar. This webinar is being recorded and will be made available on the NIDIS and Southwest Climate Hub YouTube channels and web pages. My name is Emile Elias and I'm the director of the USDA Southwest Climate Hub. This webinar is truly a collaborative effort. I'd like to acknowledge and thank the collaborators in producing this webinar. They are Adam Lang and Joel Lisonbee with the National Integrated Drought Information System, or NIDIS. Joel is the Regional Drought Information Coordinator for the Intermountain West with NIDIS. I would also like to thank the National Drought Mitigation Center in Lincoln, Nebraska, and the USDA Northern Plains Climate Hub in Fort Collins, Colorado, and the Drought Learning Network, which aspires to link climate service providers and land managers to foster drought resilience. I would like to begin this webinar by acknowledging that the land each of us is on today is the ancestral lands of Indigenous cultures, and to pay my respects to their elders and chiefs, both past and present. As we are all in different parts of the country, this will be different for all of us. The land where I'm speaking from is the ancestral lands and territories of the Ute, Apache, the Pueblos, Hopi, Zuni, and the Dene or Navajo Nation. We think it's important to provide this acknowledgement because the narratives of this land and region have long been told from one dominant perspective without full acknowledgement of the tribes who lived on this land before. This is also important because many of us are land managers or work in support of land managers, and we strive to manage the land well for future generations and for the good of all. Thank you for your attention and respect in acknowledging this important history. The format for today's webinar will be a presentation on the Drought Monitor followed by time for questions led by Joel Lisonbee. And then we will hear about Grasscast, followed by more time for questions, again led by Joel. I would like to invite you to please use the question box to record your questions at any time during this webinar. Don't let your questions slip away, and then we will answer those at the designated time. Our first speaker is Brian Fuchs, and he is a faculty member and climatologist at the National Drought Mitigation Center, housed at the University of Nebraska. Brian oversees the monitoring program area at the NDMC and has been a U.S. Drought Monitor author for 15 years, since 2005. Brian is the liaison between the NDMC and the USDA Office of the Chief Economist for the coordination of several cooperative agreements, which include activities with the USDA climate hubs. Brian?
Good afternoon, everyone. And just to check, is everyone seeing my full screen slides?
Yes, looks good.
Okay, very good. So what I'm going to do here briefly is go over the regional and drought update and also quickly on the outlook. Before we get into the Grasscast, it's always good to get a perspective of what the region is looking like as far as drought, where are the hot spots, and I just came off of doing 2 weeks as the lead US Drought Monitor author, so I've really dug into a lot of the data, and I'll share some of that with you today. So here is the current US Drought Monitor map. And you can definitely see that there are some differences between the east and the western parts of the country. Over the east, not a lot of drought to speak of, but as you get into the high plains and central plains and make your way into the Rocky Mountains and especially into the southwest, we see some definite drought issues that have been developing here, especially over the last several months. As we zoom into these regions, this is the USDA Northern Plains Climate Hub region, and you can see that even in this area, Colorado is standing out and Wyoming's starting to catch up with the amount of drought and the intensity of drought that's being depicted. On the table, you can see where I've circled that at the start of the water year, so going back to October 1st, only 5% of this region was in drought at that time, and we had no severe extreme or exceptional drought at that point in time. Currently, of the Northern Plains region, we have 41.26% of this region in drought, 19.08 in severe drought or worse, and a little over 5% of the region is in extreme drought, and that's being designated by the red. If we go back a year ago even, we can see that there was no significant drought really to speak of, and even at the start of the water year. If we go down to the Four Corners region, I think it's even more of a continuation of the same, what I would call bad news, that 91.6% of this region is in drought currently, compared to a year ago where we only were at 3.81%. The start of the water year, so October 1st, we did see a little bit more of this region in drought with just under 43%, but most of that was confined to D2 or severe drought or moderate drought. We really didn't see any of that extreme drought on the map at that point in time. So realistically, a lot of this drought has developed quite rapidly, and even in a dry part of the country, we can still see droughts that develop in a short period of time due to the nature of the climate that we've been seeing, which has definitely been hot and dry. So how did we get here? So going back to last year, this is what the Drought Monitor map looked like a year ago. And we can see in western parts of New Mexico, that was really the only place that we were looking at drought in the entire region. We had several areas that were being designated in the yellow or abnormally dry. But for the most part, you know, even in parts of Colorado and Wyoming, where we're seeing a lot of drought now, and into western Nebraska, we're not seeing anything a year ago at this point in time. So where were we at the end of 2019? So by the end of the calendar year last year, we could see the Four Corners region really starting to boost up with a lot of severe drought, especially right at that confluence of the four states. Western Kansas and eastern Colorado, we're starting to see more of that dryness develop. But if you look into northeast Colorado, almost all of Nebraska, almost all of Wyoming, there was no drought really to speak of. And even much of Arizona and New Mexico at that point in time. We had some dryness developing, but no widespread issues of drought that we were following. So that takes us to May, the beginning of May of this year. And even at that point in time, we don't see a large expanse of drought like we do right now. Really looking at eastern Colorado and western Kansas into the Oklahoma and Texas panhandles and the southern parts of Colorado and northern parts of New Mexico. Those were really the areas that, you know, by the middle part of the spring season, we were really focusing on the dryness in those areas compared to the rest of the region, which realistically, yes, there were some dry spots, but not really anything that was standing out as far as drought developing as we started May of this year. And why is this important? Well, looking at this slide, when I take the northern plains, the southern plains of the Southwest, and look at them individually, this is the historical time series of the Drought Monitor for those areas from 2000 to present. And you can see, looking at the northern plains, there has been a lot of ongoing drought in this region throughout the entire last 20-year period. We go to the southern plains and we see quite a bit of the same pattern. We see more peaks and valleys, meaning that drought has flared up and kind of diminished over time, but we still see those patterns. And then even in the Southwest, if you look at this map, it's hard pressed to find the areas of the time series that we did not have drought. We have heard a lot of scientists talking about that this hasn't been a single-year drought period or even a multi-year drought period, but really developing into a multi-decadal pattern that we've seen drought pretty much consistently over the last 20 years. And when you look at these three regions of the country, the Southwest definitely does stand out as being the most consecutive years of drought taking place, but all of them are behaving quite similarly, that drought has really not subsided for any long period of time. We've had these ebb and flows of better periods, but not really this diminished long-term period of drought that we've seen in other areas of the country. So that's something that's really concerning, and something that we at the Drought Monitor and the group of authors are really paying attention to that. So the seasonal the seasonal outlooks are actually going to be updated on Thursday of this week. So these are quite dated. They came out the 16th of July, but they still are something to look at. So this is for August, September, and October, which came out in July. And look at the temperature outlook on the left and the precipitation outlook on the right. So far through the first 3 weeks of August, we've really hit those spot on. We have seen the above normal temperatures highlighting the area of the west, especially the southwest, and we've seen this dry signal over the Intermountain West and into the southwest. The monsoon really hasn't developed too much this year. And so on the monthly drought outlook, which came out at the end of July, we were anticipating the expansion of drought throughout a lot of the West, even starting from the western areas of Nebraska and Kansas and going west. And the yellow areas were areas that we were anticipating drought developing. And if you look at if you go back to that first slide that I showed of the current map, the outlook at the end of July really was hitting this pretty good. The seasonal drought outlook, which came out again, that's going to be updated this Thursday as well. But when we looked at the seasonal drought outlook, it wasn't showing as much of that expansion when it came out in July. So it's showing you how rapidly some of these conditions have been changing, especially in the Four Corners region and in through parts of Wyoming and Colorado. That most of the expansion was anticipated in portions of Texas at this point in time. It's going to be interesting to see on Thursday what this map looks like. I anticipate it's going to look a lot more like the monthly drought outlook that we saw at the beginning of August. I'm guessing that the seasonal drought outlook that's going to take us at that point in time through the end of November is going to look more like that. But we'll wait and see how those products come out. But what that means overall is the drought situations that we're looking at are not necessarily going to be going away anytime soon. They're going to be persisting, and we're really going to be anticipating what that winter season is going to look like, especially in the mountainous regions. Just want to recognize our partners that we work with a great deal at the NDMC, and I'll put up my contact information here with my email and my office phone number. I'm still working at home, so the best way to reach me is by email. And Joel, I'll let you moderate any questions that anyone would have for me. Thank you.
Thank you very much for that, Brian. Very interesting information. Just a reminder to attendees, if you have a question, pop it into the question box. I'll get things started by talking about the monsoon. Brian, you mentioned that the monsoon hasn't happened yet this year. Is there still time for a monsoon to happen, or are we too late into the season to see a southwest monsoon?
You know, I think the full impact and effect of the monsoon season is going to be diminished for this year. I would definitely say it's going to be a miss. There have been areas of New Mexico that have benefited from some of that monsoonal moisture and even into portions of southern Colorado. But when you look at areas of Arizona, southern Utah, southern Nevada, southern California, it's definitely been a miss. There has been some tropical activity that we can pay attention to and see if that's going to help the region at all going forward. Pretty much the monsoon this year has added a little bit of humidity into the air for much of the Southwest, but the precipitation's been hit and miss. I think parts of the Phoenix metro area received their first rainfall last night since about the middle of April. And so that's really a highlight of what we're seeing. And I guess in Arizona, it's good to bring up too, not only has it been dry, but in July, they had their hottest month ever for the state. And those records go back to the late 1800s. So it's a coupling of both that heat and dryness. And again, the monsoon really has been a miss.
Okay, not good news, but thanks for explaining that. We've had a question come through that asks, as we look into fall and winter, how does that look for precipitation?
The best answer I have for that is let's wait until Thursday when we get the updates of the outlooks, and those can take us. I only showed the 3-month outlook on the maps that I showed here, but there are other time periods to look at, and realistically, until we get that update later this week, I don't even want to put a projection out there.
Okay, I might add to that, Brian, just one little bit. The Climate Prediction Center has flagged that there's an increased likelihood of a La Nina building. It's currently happening, and it would peak through winter. Would that have an impact on precipitation patterns through, especially the drought-stricken west through winter?
Yeah, that's one thing to really pay attention to is, the El Nino and La Nina cycles definitely impact the winter season predominantly. So that's something we're going to have to pay attention to. And then it has to behave the way we would anticipate them to behave. It seems like several of the last El Nino and La Nina events that we have had have not behaved in that traditional manner that we align them with. So maybe. It's not a great answer, but or very scientific, but it's probably my best answer right now.
Okay, and I think we've got time for one more quick one. That we've had one last question come through, and it's generally about the increasing temperatures, at least a trend toward increasing temperatures across Utah, Wyoming, and Colorado. And the question is, do these increasing temperatures correlate with the observed longer-term drought conditions on the western slope? Is there a link between the temperature increase and drought?
Right now, I would say that if we looked at the last 20 years and looked at the temperature trend during that time and correlated that with the types of droughts we've seen over the West, I think there would be a pretty strong correlation. Now, if we wanted to have something that was based on a longer period, we can look at those longer trends and see what temperature is doing. We've actually done some of that work at the National Drought Mitigation Center through our Drought Risk Atlas, and we have some trend products that are up there now. And depending on the time scale you look at, again, the most recent decades, the Southwest definitely pops up with some of those trends. But as you go into longer time scales that go from the 50s on, some of that signal gets diminished. So it really depends on what periods you start looking at how substantial that temperature trend is. But in any event, warmer temperatures are definitely going to be contributing to drought in the West. And again, the snow accumulation at the higher elevations and how that snow gets harvested for water during the runoff portion of the season as well. So those temperatures definitely are playing into management and decision making throughout the entire Western U.S.
Great. Brian, I'd like to personally thank you for taking your time this afternoon to share your wealth of knowledge and expertise with us this afternoon. Emily, I'm going to pass back to you for the rest of the webinar.
Thanks, Joel. Thanks, Brian. Brian, I wonder if you could put a link to the Drought Impact Reporter into the chat box for everyone, given the upcoming impending situation. It might be good for folks on the ground to know about that tool. And now I'd like to introduce and welcome my friend and colleague, Dr. Dannele Peck. Dr. Peck is director of the USDA Northern Plains Climate Hub based out of Fort Collins, Colorado. She joined the USDA Agricultural Research Service in 2016 and led the GrassCast rollout process in the Northern Plains in 2017 and beyond. She's trained as an agricultural economist and specializes in agricultural decision-making under risk and uncertainty. Dannele?
Great, thank you, Emily. Just do a quick check that you can hear me and you can see my full slides.
Looks great, we can hear you.
Wonderful. Thank you, everyone. I'm excited to share GrassCast with you today. To keep it simple, we're going to talk about what is it and how do you use it. Emily already alluded to the fact that today's webinar is a partnership, and GrassCast is no exception. GrassCast is the effort and the outcome of dozens and dozens of people who have contributed to it. And so it began as an idea between a researcher at USDA Ag Research Service, Justin Derner, and Bill Tartan at Colorado State University. And then it blossomed from there and included contributions from Brian Fuchs, who you just heard from at the National Drought Mitigation Center, and several other researchers at other universities. Also, in addition to Ag Research Service, our other USDA agencies have also played really important roles in this. And so a special thanks to NRCS, who have helped fund a lot of the GrassCast website that you're going to see here in a moment, and a lot of the outreach that we do. ARS has supported the development of this tool. And then the Climate Hubs, Emily and others have contributed a lot of their time. So this is truly a multi-institutional multi-university and a one USDA effort that I'm really proud of. So let's dive in. So all spring, we wait and we watch out our windows, and we wonder if there's going to be enough grass to support our livestock out on our native rangelands. This is what my window looks like from Laramie, Wyoming. We're lucky if we get to see snow into April, May, and sometimes June, but we sit and we wonder, will we have enough grass this summer? And in the past, the best thing we could offer our rangeland managers and our ranchers for a forecast to try and anticipate what might happen during the upcoming growing season was our seasonal outlooks that Brian was just sharing with you from our friends at NOAA. And so this is just an example of an old 3-month precipitation outlook for the an upcoming summer growing season. And this is what we had to share with our ranchers and our range managers when they would ask what might we expect during the upcoming growing season. And I would hand this to our ranchers and explain to them how to interpret the seasonal outlook. And the very first question they would ask is, so what does this really mean for me as a rancher or as a range manager? And to be honest, for a very long time, I didn't have a great answer. My answer to them was, well, I was kind of hoping you guys would know what this meant for your rangelands. And I realized, our GrassCast team realized that was a lot to ask ranchers and rangeland managers to do that translation for themselves. We all know that the relationship between precipitation and how much grass grows out on our native rangelands is pretty complicated. So we were asking them to do a lot in that translation. So we realized we, as scientists, could take that extra step for them. And that's when the idea of GrassCast was born. Instead of handing them a precipitation outlook and telling them, good luck, I don't know what this means for you, we can now hand them GrassCast, which is a grassland productivity forecast. And, all right. Okay. And so, GrassCast, if we dig into what is that map, here's how you interpret it. Find a location on this map that you're interested in and make note of its color. And that color is trying to tell you this. Based on the weather we've observed up to the date that the map is made, and then plus seasonal weather information forecasts that are trying to look out into the future of the upcoming growing season. So based on those two things, observed weather up to the date.
Hi, this is Dannele. This is Joel.
Yeah.
I'm sorry to interrupt. We can't see your slides right now. Could you try to?
I wondered. Yep, I'm going to stop, Joel. It did flash, and so I wondered if you guys had lost it. So hold on, I'll stop sharing for a moment, and we will reshare. Apologies, everyone. Joel, is it back up?
Yes, we can see that again. Thanks. Sorry for the interruption.
Okay. No, apologies. I'm not quite sure why that happened. Okay, so as I was describing, when you look at the GrassCast map, how we put this thing together is using weather observed up to the date the map was made, then looking forward into the future, the rest of the growing season based on weather forecasts. And together, we put those together to try and give you an estimate of how well we expect grassland productivity to be in your area. And that's all some percentage higher or lower than your area's 30-plus year average. So everything we present today is relative to your area's long-term average. So I don't want GrassCast to be a black box. I know we've got some NRCS folks on here who are really knowledgeable about rangelands, and we've got some researchers on the phone. And we've got some citizen science folks. So just a very quick overview of what the GrassCast model does. Again, you've already heard this part. We put observed weather together with a forecasted weather for the upcoming growing season. We feed that into this grassland simulation model known as DayCent, and Bill Parton developed the DayCent model with colleagues at CSU. DayCent takes that daily weather information and translates it into how much evapotranspiration we expect to happen over the upcoming growing season, right? And evapotranspiration is how much water is moving up through the roots of that plant and out its leaves and out of the soil. And the reason we care about how much of that happens over the growing season is that it relates really closely to how vigorously our rangeland plants are growing. How green are they and healthy and robust versus how kind of brown and crunchy they might be if it's hot and dry out. And then finally, this greenness, this NDVI index, what's nice about it is that it's available across the entire Western landscape. So it helps us, it's what makes in part possible to produce GrassCast for a bigger region. But we don't just care about greenness. There's one last step in the GrassCast process, and that's translating it into the thing we really care about, pounds per acre of vegetation for the season. And that's how we get the GrassCast map. Now, we took this initial GrassCast map out to our friends at NRCS and University Extension all throughout the Northern Plains way back in 2017 and asked them, what do you think about this product? And the very first thing they told us was, please don't make us place our trust in a single forecast map. We know how hard it is to forecast precipitation for the Northern Plains region, especially in the summer, so please don't ask us to trust a single forecast map of rangelands. Instead, why don't we replace that weather forecast with 3 different possible scenarios? And that way we can do some scenario planning. And so that's what we did as a GrassCast team. We took that feedback and we said, okay, instead of using the seasonal outlook forecast, let's instead do these 3 scenarios. What if? What if precipitation from May through August, that's kind of the typical growing season, at least up in the Northern Plains region, what if precip during that period is above normal? Then what would the GrassCast map look like? What if it's just near normal? How different would the map look then? And finally, what if precipitation is below normal? What do the GrassCast maps look like in that scenario? And from that feedback, that idea was born the current GrassCast product. It's a 3-map product, and I know that can look overwhelming, but I'm going to walk you through it and kind of, again, teach you how do you use this thing. So what you're looking at here are the GrassCast maps that we published back on April 14th of this past spring, so April 14th of 2020. This was our first GrassCast maps for the Great Plains region for the 2020 growing season. And the first thing you do to use these maps is choose a location that you're interested in. And you choose that location, the same location in all 3 maps. I've chosen a location here that's near Colfax County, New Mexico, because the colors, I think, tell an interesting story. This was way back in mid-April, again, trying to look forward to the end of the growing season and give you some sense for how many pounds per acre compared to your average might grow out there during the upcoming season. So I'm going to start on the left. What if, again, it's April 14th, what if precipitation from April 14th all the way through the end of the growing season, August 31st, what if it's above normal? How many pounds, or how well will our rangelands grow? And so the color on this map is kind of this turquoise color, which says if you get above normal precip for the entire growing season, this area we would expect to have 5 to 15% more pounds per acre than that area's long-term average. But what if we're wrong? What if precip for the upcoming growing season is only near normal? Well, then we look at the middle map. And again, check the color of your location. And in this case, it's orange. If this area were to get near normal precip for the rest of the growing season, our model suggests that they should expect 15 to 30% less pounds per acre than average. And finally, what if the spigot turns off for the whole growing season? That scenario that none of us like to think about, but is unfortunately kind of been the reality this summer. If it's below normal precip for the rest of the growing season, our models were suggesting that this area should expect 30% less pounds per acre or worse. So that's how you interpret GrassCast. I wanted to use this particular location as an example because way back in mid-April, this area drew our eye. We were immediately concerned for it because you'll notice that in the middle map and the right map, they were both orange or red, or you'll see some areas up in Colorado that in the middle are yellow and on the right are orange. This was telling us way back in mid-April that 2 out of these 3 scenarios were likely to result in below normal production. And so that was a signal that, hey, we better dust off our drought plans and start thinking about what we'll do if one of these scenarios becomes reality. This map gets updated every 2 weeks throughout the growing season. And so I'm going to skip ahead. Every 2 weeks, we post new maps on the GrassCast webpage, and we'll skip ahead to the most recent set of maps. These are the maps produced on August 11th, and we'll put out a final set of maps after August 31st. But this is the most recent. I've circled that same location to kind of ask, where are we? Where are we at? We've now observed most of the precipitation for the growing season. We only have a couple of weeks left where the precipitation may or may not, be helpful. What if? So what if this area receives above normal precip for the rest of the growing season, these last 2 weeks? Well, unfortunately, all 3 maps show red, that no matter kind of what happens over the next 2 weeks precipitation-wise, this area we are estimating will have 30% less pounds per acre or worse. And I keep saying or worse, and so you might be wondering kind of what does that mean? If you go to the GrassCast website, and I put the link here at the top, there is a zoomable map feature where you can search for or zoom into each individual grid cell, and these grid cells are 6 miles by 6 miles in size. And so I've zoomed into a grid cell that's within this same county, Colfax County, New Mexico. And I said on the previous slide it was 30% less or worse. Here, if I click on the grid cell, I get more specific percentages. And so, if we get above average precip, so the map on the left, this area we're estimating will have about 36% less pounds per acre than normal. Over on the opposite end of the spectrum, if they get above normal precip from this point forward, we'll expect about a 42% loss, 42% less than your average production. Now, if you're in western New Mexico or central New Mexico, you might be wondering, why are there no colors? And in the past, we would have said, oh, shoot, we can't produce it for you. But I'm super excited to let you know that this summer, we did expand GrassCast to all of New Mexico and all of Arizona. So this is the Southwest GrassCast product. One thing to note is that in the Southwest, things are a little different down there. And so we actually do have a separate spring forecast, and that was April through the end of May, and then a separate summer production forecast. And the summer production runs from June through the end of September. And so here you're looking at the summer forecast maps, and again, you can come here and click and zoom in however you would like. I'm going to go back to the static images that we saw earlier. Again, let's just pick a location and test our understanding of how to interpret GrassCast. This is Pima County, or near Pima County, Arizona. Again, it's August 11th. Precipitation through the rest of the growing season isn't going to make a big difference. A lot of the outcomes, seem baked in. We get red no matter what. But if you go to the zoomable maps, again, what is 30% or worse? For Pima County, it still actually is a big difference. If we get above average precip from this point forward, GrassCast estimates that we'll have losses around 38%. But if the spigot remains turned off for the rest of the last few weeks of the growing season, the losses could be as high as 77%. So even though the color didn't change, when we came to the zoomable maps, we actually did see that there is still a big difference in this region, depending on what happens over the next few weeks. I wanted to end on a little bit more optimistic note. This is a map for right on the boundary of Socorro and Sierra counties in New Mexico. If we get above average precip from here on out, we might actually have a little bit of above average production, 5 to 15% above. If it's near normal, then we'll have some slight losses, 5 to 15% less. And if the spigot remains turned off, then losses hopefully should be limited to 15 to 30% less. So it's orange instead of red. Now you might ask which of these scenarios is more likely. This is where we come back to those outlooks that Brian was showing you. This is the outlook for the next 2 weeks through the end of August. And for this area in New Mexico that I was just looking at, unfortunately, NOAA their models are leaning towards below normal precipitation, about a 45% chance. So the dice is unfortunately a little bit loaded towards below, but of course it's still a roll of the dice. So there is still a 33% chance that we'll have near normal or a 22% chance that we'll have above. But if we go back to our maps, you know, the most likely outcome is below average precip. So that's the GrassCast map on the right. The next most likely is near normal, and that's the middle map. And so if you're a rangeland manager or a rancher facing this situation, right, it's unfortunately, it's time, if you haven't already, to be taking some steps to deal with having much less forage. And I'm an ag economist. I'm not a rancher. So these are just some of the management suggestions that we hear about from other producers. Kind of weaning your calves early, probably having to reduce your herd size. So if you're a cow-calf producer, you know, culling those low-producing cows or those late calvers. If you're a cow-calf yearling operation or a cow-calf stocker operation, you have more flexibility, right? You get to sell those yearlings first before you have to start dipping in and selling that valuable breeding stock. And so, you know, do think about flexible stocking options that those yearlings bring to an operation. Even though it means that the cow-calf herd is smaller, those yearlings you can flex up and down in response to grass availability. This doesn't apply to all regions, but maybe you can move some cows to crops, stubble, or a dry lot. There's lots of other ideas out there. The National Drought Mitigation Center has a wonderful webpage dedicated to kind of ranching in drought, so go check that out. And of course, be sure to reach out to your nearest USDA service center and your university extension folks to learn about programs or technical assistance that they have. There's lots of opportunities out there to try and help make your ranch or your rangeland more resilient for the next drought. Last thing I'll note, I'm watching my time here and I'm approaching 20 minutes. I do want to say that GrassCast is not perfect. It's a model. It has limitations, and so it's really important that you continue to use lots of other sources of information and to take your local context into consideration. And so, for example, GrassCast can't tell the difference between palatable grass species that your livestock are going to enjoy eating and get fat and happy on versus weedy, unpalatable species like cheatgrass. All grass, the only thing GrassCast knows is that your pasture is below average production this year. It doesn't know if that's cheatgrass or something else. So you have to know the conditions in your pasture, and also need to know whether your pasture tends to be more or less vulnerable to drought than pastures in your local area. So with that, go and check out our GrassCast webpage. There's a wonderful introductory video. There's some tutorials about how to read the maps. If you're into the science and want to know more, there's some science webinar recordings there. And then also under the FAQ tab, there's some links to our publications. And we do have a new paper coming out soon in Ecosphere. We are always looking to where to expand GrassCast next. So let us know where you think it's needed, but also let us know where there's long-term clippings data. We can't expand GrassCast without good long-term clippings data. And so we always welcome new partners. We've been in conversations with FPAC about how GrassCast might be able to support some of their programs. And so keep an eye out for us and let us know what you're interested in. with that, I'm going to end so that we have just a few minutes, I think, for questions. This is my contact information and Emile Elias, who is our Southwest Climate Hub connection for GrassCast. Check out the Climate Hub's website. Thanks again to USDA for the funding and the National Drought Mitigation Center, who also received some funding from the Office of the Chief Economist at USDA. So thank you for all of our funders. And with that, I will turn it back over to Joel.
Thanks, Dannele. Very interesting. I've had a few questions come in, and just to set expectations, I don't think we'll have time to get to all of them, but there were a few questions, 2 of them to be exact, that related very closely to what you just said about ideas about expanding GrassCast to other regions. We've had a request for the Flint Hills of Kansas, which is a beautiful part of Kansas, my favorite part of Kansas, I think, and also California, Nevada. Now, if people have ideas of where to expand GrassCast to, would that be just an email to you, or is there a better way to communicate that?
Nope, an email to me would be just great. I am definitely one of the main contact folks for the GrassCast team, and I pass those messages along to the team. If you didn't grab my email address, you can also go to the website, and there is a kind of a contact us page, and you can drop me a message there as well, and it'll make its way to my email. Expanding eastward, I'll say the challenge is that those systems become more precipitation driven rather than evapotranspiration. Remember, step 2 of the GrassCast model was about ET. So as we move east, those relationships really start to change, and the current GrassCast model starts to not work properly. But we would love to partner with someone who has that, kind of eastern grasslands experience. Moving westward, we have talked about California and have had some requests and are searching for long-term data sets to try and help make that possible, as well as Nevada. So if you have any leads on long-term rangeland clippings data, drop me a line. We'd be really interested in chatting.
Great. I hope somebody who's online can make that connection for you and can get in contact. Another question on the GrassCast maps, what does no data mean? Can you expand on that a little bit?
Sure. Yep. I just gave an example from Kansas that sometimes it means that we can't move that far east because our statistical relationships between evapotranspiration and greenness and pounds per acre start to kind of fall apart. The ecology of the system is just different. So sometimes off to the east, that's why there's, it says no data. What it means is there's no GrassCast estimate for that area. For areas to the west, like in western Wyoming and western Colorado, the reason we are unable to go to those areas currently is because of step 3 in our process, and that's NDVI. That's a satellite remotely sensed piece of information, and those satellites can't see through the forest canopy down to the grass that's growing underneath it. And so for those kind of mountainous and forested areas, step 3 falls apart. And so we can't, unfortunately, currently we can't produce GrassCast for areas like that either.
All right, well, thanks for explaining that. Is there anywhere that someone can find absolute values in terms of pounds per acre that apply to the percent changes?
Yeah, great question. If you go to the website, there is a tab on the left-hand side that says historical production. And if you click on that, you'll find several different Excel files that you're welcome to download. And what those represent, we say historical, but it's really GrassCast historical estimates of production, either for every county or every grid cell. And so you can go in there and see, what does GrassCast think the average production is for this area? And what does it think the min and the max is over the last roughly 30 years?
Oh, I think we might have lost you there for a minute, Dannele. Are you still there?
I am. Can you hear me, Joel?
Yes, we can hear you now.
Okay, apologies. I don't know if you heard the part about the historical productivity tab on the website.
Yeah, that's probably a good place to pick up again.
Okay, sorry for that connection problem. So on the website, if you go to the Historical Productivity tab, there are several Excel files that you're welcome to download, and they contain our GrassCast estimates of historical production, either for every county or for every grid cell. And so these are not actual historical like clippings data from the field. These represent what GrassCast thinks would have grown in each of these areas over the last 30 years, according to our model. So it's kind of the modeled historical production, and you'll find a mean there and a median, a min and a max, and what years the estimated min and max happened in. So they're pretty fun data sets. Be sure to go check them out.
Thanks. We're at the end of the scheduled time for the webinar, so my apologies that we haven't had time to get up to all of the questions. But if you'd like to ask more questions, Dannele, should they just go to the website and go to the Contact Me page if they have some questions and suggestions for the tool?
That's a great tip. And there's also an FAQ tab on the website where we have some of our frequently asked questions and answers. So if you don't find your question and answer there, feel free to send me either, again, a note through the contact page or directly an email to me.
Great. Dannele, thanks again for your time today and sharing your vast amounts of knowledge on the GrassCast with us. Emily, I'm going to pass back to you to wrap it up.
Excellent. Thanks so much. Thanks to everyone for joining us today. I especially want to thank Dannele and Brian and Joel for managing our questions so well. If we will be able to respond directly to you as well. We'll know who the questions came from in the chat box. So possibly look for an email from us if we weren't able to answer your questions. And we also ask that you complete a short survey to help us plan future webinars and modify the tools presented to best suit your needs. So that will be launched now, and you can find more information about NIDIS and this information on drought.gov. Thanks very much. This concludes our webinar.